All right. Okay. I was reading to your notes from your drawings and stuff like that, your suggestions and stuff like that. I know that you want to shrink, make the PCB a bit smaller, but the problem is if I do that, you told me that you want me to spread them, those small caps, spread them out a little bit more. But the problem is if I do that, and then the PCB is going to increase in size, so I cannot keep increasing the size of the PCB. And by the way, those small caps, they are 35 millimeters in diameter, and they still have plenty of space between them. I don't think it's a big deal to have them that close. Also, the suggestion of the, I think you wrote here 250 millimeters. Yes, I can do that, but I placed the measurement here, as you can see. That's the 215 millimeters. You will see here on here is 250 millimeters. The problem if I can reducing the size of the PCB, I'm not gonna have space for the fuses. As you can see, I already traced a line to see what I am right now. So if I do that and then I have to eliminate the fuses, we don't want to eliminate the fuses. We want to eliminate. I mean, we want to have the fuses on the PCB for security purpose for the audio amplifier. I tried to figure out the ways to. I rotated to a 90 degree and I was able to save some space on the PCB. Going to copy this one here, just to show you. Just gonna copy this one here. I was able to save some space. Let me copy one more time. I don't want to mess that up. This one here, so I really don't want to do that. So okay, I'm gonna place it here. So I was able to save just a little bit more space, a few millimeters more. So this is the actual before, and yeah, I think that's fine right here. Okay, let me see. I gotta make sure. Okay, a little bit more. That's what I do. Creep. Let me see. I gotta. Okay, one more. Let me see. I'm really close. Yeah, that's right. So I was able to save a few more millimeters. As you can see, I trace a line, and you will see that I actually save a few more millimeters of space. Let me see how much space I save. Let me see. I guess we have saved it just a few millimeters. Let me see. I gotta see. Oh yeah, we got there you go. We got 17. Let me see, 17.250 millimeters. So I was able to save that amount of space on the PCB. So for now, this is what we have right now. I was thinking that I might to save it even more space, but we needed to either remove this resistor and put it somewhere else to drain those caps. So that's the idea that I have, maybe because I want to have it as symmetrical as possible to look good on the PCB. So also this is a good idea, because I think if after you place the terminals, the rounded terminal, what did I say there? Let me see. Round. Oh, there you go. I got one here. This is fine. Let me split the group. This one is fine. Let me copy this one here. Maybe this drawing is too big. Probably I gotta look for the real one and use the actual measurements. I needed to do that. So one sample, I gotta rotate this to a 45 degree and copy one more to 45 degree also. 1, 2, there you go. And then just to place it there. I think this is a good idea, having in this way. Okay, I think I miscalculate the rotation. Okay, one sample. You can route out the cable. Okay, it's fine. It's fine. I know we right there, something like that. Depending on how you're gonna rotate the cable is gonna be flexible. So we got plenty of space for that. So that's for the star ground. So oh yeah, and I also made the macro. These 4 terminal screw standoff. Yeah, standoff terminal screw. And I centered out the screw for the for the PCB, so it can be held onto the chassis securely. And yeah, I gotta calculate other stuff. Maybe I'm going to be able to shrink it even more if I can. Right now, this one here is I think I gotta, let me delete this one here. I'm gonna measure this one here. This one here is 152 millimeters. So I think I might be able to shrink it even more from the size, so the PCB is not gonna be that big like the first one, like this one here. I'm gonna try to do that. Also, I know that we need to have more space for the heatsink of the bridge rectifier. So also I already moved it a little bit, a few millimeters in the front. So I gotta make a macro with the notes that you gave me. I think you gave me the notes, I think. I saved them. Let me see. You say I changed the numbers of screws. Okay, I can do that. Move the terminals. Move on of the terminal screws. Okay. Okay, that might be a bit difficult. And moving those small caps, that might be difficult. If I do that, I'm going to increase the size of the PCB, and we don't want to do that. But I think it's possible to spread them out a little bit more. I think it's possible. Yes, it is possible. So it will be more symmetrical, matching those bigger caps. So I think it's possible. So I will continue here. I'm gonna try to look for best options for the fuses, the output fuses, and I think I might be able to shrink it even more. So we need to have space for the bridge rectifier, for the heatsink of the bridge rectifier, space them out the caps a little bit more, and try to shrink it as small as possible to have a smaller numbers. So I'm gonna try to do that the best I can. So even though it's difficult, it's difficult to shrink it. So wait, this is the 250 millimeter. That might be difficult to do unless we remove something from the PCB. We don't want to remove something from the PCB. Or I want to keep shrinking the best I can. So I will continue with the caps, the small caps, to spread them out a little bit more, so they will have more space between them. It's possible. That's not a big problem. So, oh yes, forgot to explain the reason I have those caps there, just in case one sample I cannot afford to buy those caps, so I can use a simple caps that have 10 millimeter pitch distance and 35 millimeters in diameter. They are easy to find. They are easy to buy. I can buy those. It's no problem. So that's why I have that option there. So yeah, that's option there. I mean, it's not for sale. This is not for sale. Maybe I'm trying to do something for sale. This is not for sale. This is our own design for the Class AB audio amplifier, high fidelity. All right, that's it for now. Take notes. This is PSS version 1.1. I should change it because I did some modifications today, so this should be 1.2. So when you look at this video, you know it's 1.2. So I gotta save the file as version 1.2. So keep looking at the share folder, the version that we are working with it. All right, that's it. Gonna cut the video, and I will continue trying to figure out best ways to shrink the PCB the best I can, not to have a way too big. At least I remove a few millimeters. That's good. We have removed it. I have removed 17.2 millimeters. That's good. So I was able to remove those. All right, I will continue on the design, and I will make more videos about this Class AB audio amplifier design, original Class AB audio amplifier, PSS version 1.2. All right, that's it.